Hello, my name is Samar Gal. My student number is 371703, and this is my assignment 2, building a computer network, part of my Unit 19 computer networking course. And let's get straight into it. So the scenario I was given was you have taken a job as a junior network engineer at a taken a job as a junior networking engineer at a company that designs and installs networks for organizations. Your supervisor has asked you to design, install, test, and evaluate a network in a small branch office of one of its customers. The network requires a server and 3 workstations connected by a wired network and should also provide Wi-Fi access. Internet access and remote terminal access should also be provided. The network will require 2 groups of users, managers and assistants, which each with their own shared folder. The managers group should have full access to the assistant's shared folder, but the assistant should have no access to the manager's folder. The network should be scalable, but does not need high availability features. It should be secure and protected from common threats and should be easily maintained. Costs should be kept at a minimum while providing a reasonable level of performance. So we started by planning my time, how long it would take for, as shown in this Gantt chart. I planned my evaluation, my explanation of the network design and planning strategies, my design, then my development configuration, my testing, my review, how I would optimize, and finally my evaluation. So we started with an email to my client to explain why it is necessary to design a network and plan its implementation rather than just going ahead with installing it and how this ensures network meets the organization's needs and goals. In this email, I explained that a well-designed network plans are always far better as evidenced below. It creates a good efficient network platforms. A good network performs quickly and efficiently. With a plan, you can be assured that your network will run at a constantly high performance. Stability. Network should have suitable platform for applications. A well-designed network design plan can ensure the network does not lead to the loss of an entire client server session. Makes room for scalability. So a suitable network designs access possible changes in the business without the need for a total redesign. They take note of additional computers, potential required office applications, and an an increased number of users when starting with a plan. So when the business grows, we do not need to start from the beginning. Work collaboration is made easier. To maximize work performance, it is worth investing in properly laid out network infrastructure, and the network design should also address this situation. Speed increase. When the network is designed correctly to the nature of the business, the effect is immediate, with fast communication flow and smooth transactions. Once all the points are considered and we are ready to execute the network design plan, we can finally get it up and running and have it running well. Once I had this, I then got my reply and I was ready to start my plan. I started by looking at all the risks involved with a network before I started how I would plan it. What I came up with, as shown on this risk matrix, are some of the nodes, the devices, such as the switches, which would be the switches, server, wires, and monitors being damaged. The switch I deemed the most dangerous, as I plan on doing a star topology, and if this goes down, the entire network will go down. So plans to make sure that that is safely secure and unable to be tampered with is important. Others, things like the wires, router, and server, again, very important that these are locked up or covered and not easily damaged or tampered with, so that the risk can be minimized. Monitor damage, whilst not great, is pretty neutral, as these can usually be replaced. Theft, flooding, and viruses and malware can change from this network, as it does depend on what it's happening, but measures should be taken in place, such as locks and covers, to ensure that they cannot easily be stolen or damaged from theft or flooding, and firewalls installed to stop viruses and malware. Next, I looked at my IP addressing and naming schemes. I separated this out for the devices. For the PCs, I had them, as it's a pretty simple network, I kept with very simple names, naming the PCs going from 0 and up, and I kept their IP addressing at 192.168.1.10 and then upwards for the PCs. Then for the server, I went with 192.196.1.20, and that will go up if we ever increase on servers, and then 192.168.1.30 for the wireless router that we'll need for the Wi-Fi. As the switch I will be using will not require management, it does not have an IP address. And so here is the design of my network that I made on Cisco Packet Tracer. As you can see, it follows a star topology, with the PCs connected here, all with the PCs, servers, and wireless router all connected through the switch, and then the router connected to the Wi-Fi. This now can meet requirements with everything connected together, and everything can be remotely accessed through this setup, and also have access to the internet. As for the physical layout, the server and switches can be stored in this locked cabinet in this room, with the same room to the wireless network in that room that can be stored where it is easiest, connected through here. We then have, and then through the walls, I know this isn't particularly well demonstrated with this image, as I was a little unfamiliar with the site, but essentially it'll run through the walls or slightly on them, with covers over to the PCs in each room. Next, I got on to the issue of splitting the management shared folder and the assistant shared folder. The way I saw it, using file sharing and the security function on the shared folders, would allow me to select the PCs that I wanted to have available to these files, and which I did not. For example, if I go back to the physical layout, we'll say this one was the one up here was my manager PC. I'll make sure that one has access to both files, while these ones I will have only access to the assistants shared files, or however the layout is. As I was working through my network, each step I would run through my test plan to test that it was working correctly and efficiently. So we started by testing through that all workstations were connected through the switch. This was mostly for the PCs, and we simply sent a packet through between each PC to each IP address and back forth to make sure that everything was connected, which was a success, as you can see, and so we knew that we had remote terminal access. We then did the same with the server, and that was fortunately connected. Oh, these were all connected via copper wires, by the way. Then when we tested for the Wi-Fi connected to the Wi-Fi through the router, however, it did not work, and I had to work for a moment to find the connection issue, which I then realized was that I hadn't configured the router properly, and once I had done that, everything was connected together properly. And then I worked on the file sharing, and I tested this by having an administrator PC try and open the file, and they could not, whilst the manager PC could. So it was a success. So once I had my design for my network and its physical layout, I then So I then worked at collecting feedback from it. And from the results, everyone seemed to agree that my I gave a good justification for my the importance of why to design the network first. That my network has indeed got a server, 3 workstations, all connected through the network, and also Wi-Fi access. They believe that my network has internet access and remote terminal access. Where there was a bit of doubt was some was unsure if file sharing and security features would effectively give access to the managers, the assistant files to the managers. I tested and ensured that and showed my testing that it does indeed restrict access for the assistants. Then again, they did all agree that having the separate IP addresses and for the PC servers and routers would allow the network to be scalable. Something I believe I may have missed earlier. That was the intention of having the different names for the different IP addresses for the different devices, so more can be added. And by having the wires covered up and the servers locked away will keep the network secure and protected from common threats and allow it to be easily maintained. There was then once again some disagreement on if the cost was kept at minimum while providing reasonable levels of performances. Whilst it has used more cabling than I would like in the physical design, I did look at it, and I believe these are the lowest amount of nodes equipment and the smallest amount of cabling that could be used and still achieve their goal in this standard office layout. Again, everyone agreed that the network does follow the requirements, will work effectively, and that I have properly considered risks and how to manage them. There was a bit of confusion if my test plan was accurate. I believe this was due to the file sharing from earlier and if it met requirements, but I believe that this was cleared up. And finally, I was given the advice to improve on working on my naming conventions and IP addressing system. As I said, I kept the names simple for the IP address for the naming schemes, as it's a very simple network for them, so it doesn't truly need different names there. Although after that, I did consider that we could name the PCs either a managing PC or an admin, an assistance PC, depending on who it is for. As for the servers, I believe the server and the wireless router, they can remain the same. Fine. After this, I then looked at how I would optimize my network, and apart from the method to name them differently, like it was said, I also thought that as it was a star network and can be quite expensive with all the wiring and devices needed, by making it wireless, by having some wireless adapters, perhaps for the two PCs down here at least, it would reduce costs significantly, while also, I believe, improving scalability, as I wouldn't have to check the connectivity of all the wires needed before adding more. So let us evaluate my network as we look in from this. So the network design and implementation, I believe, has effectively met customer requirements. The network contains a server and 3 workstations connected by a wired network with internet access and a remote terminal access through switches and a wireless router as was requested. The network has 2 shared folders, with the managers having full access to the assistant shared folder by using the file sharing and security functions, whilst the assistants don't. The network is scalable, having separate IP addresses for the PC servers, switches and routers that will make the network scalable. Not switches, sorry. It is secure and protected from common threats, and easily maintained by having the wires covered and the servers locked away in the physical layout. The network keeps costs to a minimum, provided a reasonable performance by using the minimum required nodes and wires needed. The network follows all the client requirements, then works effectively according to my test plan, and has had all potential risks considered through the risk matrix, and I have found ways to manage them. To improve my network, I would recommend moving on with wireless connections, as this would reduce the cost of needing more wiring, and improve scalability, as it will be easier to connect. And these are my references as I made my network, and that is the end of my design.